All right, so we are in part 3 of our lecture series here on statistical process control in quality management systems as far as our metrology class here at Richland. So again, up on the screen, you'll see we've got this formula that we use for standard deviation. Just as a review, the Greek letter sigma, where we get the term Six Sigma in our lean manufacturing practices, comes from. It references standard deviation. So standard deviation equals the square root of the Greek letter epsilon here stands for the sum of the number or individual data minus the mean. So we square that, and then we do the divide that number by the overall size of our population. So, and this is what we use, the formula that we use to get standard deviation. So you don't need to memorize that formula. You will be given and have that formula on any type of quiz or test, but you do need to know how to actually apply that formula by plugging and chugging the numbers into from your data set into something like this in order to calculate and come up with standard deviation. So here again is the procedure. So we calculate the mean first. So you got to know what the mean is. So then we're going to subtract the mean from each value and square the difference. So we will sum all of the squared differences. So we'll divide that sum by the size of our population, and then we'll calculate the square root of the result from there. So we're going to put this into practice here now. Again, we've had the general rule about rounding in statistics. So keep your numbers all going, and then make sure that you round to the next number in terms of your data set. So here again we've got 2 digits, so we will be rounding to the third actual number when we kind of come up and do this particular calculation. So let's take a look at how this is done. So first thing we're doing is calculating the mean. So we take all of these up, sum them up, divide that by the number of entries in our data set, which is 11. So, and we end up with 47.63. Now, we can leave 47.63 alone right now. Notice the average symbol up, or the symbol up above it. So we don't necessarily need to kind of round that at this point. So subtract the mean from each data value and square each of the difference. So here we're taking the value of 2. So, and we go and subtract that from the mean that we've got. Then we square root it. We come up with this number. Here we take the next number in our data set 5. So we do the same thing. 48, do the same thing. So we have to go back and do this on each and every single one of the numbers in our data set. So, and you'll see here's all of these kind of coming out and what we get in terms of this. And now notice here we've got the 63 occurring twice, and we are doing it both times. So make sure that you do that both times. Of course, you don't have to do the calculations. If you do the calculations on this one, you know what the calculations are for that one, but you do have to keep that in your actual numbers when you kind of go through to do this. So let's take a look now here. So once we've got that, so we just kind of came up with this. We're going to sum all of those together. So notice, so where we got all of the square values now we're adding all of those up to come together with the sum here. So, all right. And we will divide that by the number of our data values. So in this case, we end up with 456.7769. So then we will take the square root of the result. All right. Once we have the square root, we're equal to 21.4. Now, you guys can plug and chug this square root of 456.7769 into your calculator. I imagine that it probably comes out to more numbers than 21.4, but I'm going to stop and say, hey, why are we only at 21.4 here? Well, if you remember our original data, we only had 2 numbers in there, so we're doing it to the third number, so we're kind of keeping that in there. So, all right. So now we're going to talk real quick about the ways that we can kind of show this to give a visual representation of that. One of those methods is what we call a histogram. So it is a common data distribution chart. So then we use this, of course, to show frequency based on the value that we want to kind of show. So we can use these in inspection reports. We can use these in data that might be used to help us prove out return on investments or ROI to get new equipment or new machinery. If that particular machinery is causing a large problem with repeatability on holding certain tolerances, then we can kind of create these type of histograms to help show that, and might be able to put that in a presentation to get some justification for new machinery and equipment. So there are several ways that we can kind of go through this depending on and break this up. So this next few slides are going to show you some different ways. So we can divide it up into a limited number of groups, or what we call class intervals. So here you see we've got class intervals that are broke apart from -16 to -6, then from -5 to 5, and then from 6 to 16. Now, in practice, when you go to break these class intervals up, know that that is based on your standard deviation results, so in what you kind of calculate. So this kind of shows, we plot this then, so we get the number of times that each data element kind of shows up in that frequency, and this is kind of giving us a nice little visual of what that would look like. So here's some examples. Let's take a look. We are going from 1 all the way up to 15. So notice how we put the frequency in here, and we can kind of plot this out. So as you take a look at it, so here's the derivation of the class intervals. So, all right. And then we can kind of say, all right, well, from 1 to 5, we've got 3. From 6 to 10, we've got 4, and then from 12 to 15 we've got 2. So, and we're just basically kind of filling that out for the frequency. Here's another type of histogram that we can use called the bar chart. So you can kind of see this, where the minimum is the 0.745. Our maximum is 0.760. So in this case, they've done it every thousandth of an inch, so which is a good way to actually do this in terms of our dimensional sizes and tolerances. So you can see our range here again. So we can kind of set this up to, and then of course we can do what we call a scatter plot or a dot plot type representation as well. So we can place and more or less put all those, and we basically plot this out. So where all of these are going to go. So, and this gives us a good idea of our distribution as well. Now take a look at this. So some of you, I imagine, have kind of seen some of this type of distribution before. So here's our frequency on there. So we got our bar graph looking that way. So we can kind of take a look here as well. And this is, of course, what we would call the bell-shaped curve. So those are a lot of different ways that we can sit here and take a look at our data. So use statistics to kind of represent that data, and then kind of get some visual aids or visual histograms to help us to kind of showcase and present that data in a way that's easier for everybody to understand.